Welcome to this video where we will delve into the nitrogen family of fertilizers. I am Andrew Prince from F-Curve Agri. When we talk about nitrogen fertilizers, we are generalizing about products such as urea, ammonium nitrate, and LAN, as well as ammonium sulphate. All of this family of fertilizers is derived from ammonia. In this video, we wish to highlight the main aspects that are key to pricing. Firstly, the global supply-demand balance gives us a directional signal on pricing. We will also look at production processes and the raw materials that are used to make nitrogen fertilizers, as the raw material cost ultimately determines production cost. We will also look at where these products are produced, the major producers and trade flows, as well as the price trends and cyclicality. Please also look at our other videos which discuss phosphates and potash fertilizers, plus our introduction of the fertilizer industry and challenges in sub-Saharan Africa. We would also love to hear from you with any questions that you may have, or just give us your feedback on these videos. We will now look at the production of nitrogen fertilizers and the global supply-demand balance. We look at supply-demand balances for fertilizers because it gives us price direction. If demand is greater than supply, prices typically go up, and similarly, if production is greater than demand, we have an oversupply in the market and prices typically soften. Ammonia, which is the precursor for the whole family of nitrogen fertilizers, is produced from a reaction between nitrogen and hydrogen. The nitrogen comes from the air around us, so it is obviously free, and the hydrogen is sourced from a hydrocarbon feedstock, such as natural gas or coal. So it is the hydrogen raw material that is the key cost determinant for the production of ammonia. Around 20% of ammonia goes into industrial or chemical end uses. The remaining 80% goes into fertilizers. The difference between the two is that the industrial sector typically does not have a season and operates for 12 months of the year, whereas fertilizer, as we know, is highly seasonal. So it's typically the variation in fertilizer demand that determines or influences the ammonia price. Most ammonia is consumed on-site, i.e. in an integrated production process. Only 20 million tons is traded globally. Moving raw materials is typically much more expensive than moving the final product. So that is the reason that we see a lot of integrated fertilizer production facilities. As the numbers show us, ammonia capacity utilization is around 81%. On the urea side, it also has some industrial end uses, but by far and away the fertilizer demand is the most important use of urea. Globally, it is the largest single nutrient fertilizer that is consumed. It is also considered the standard for nitrogen fertilizers, so throughout this video we refer to urea interchangeably with nitrogen fertilizers. In South Africa, we do have a history of using LAN as well as a nitrogen fertilizer, but the consumption of LAN has been declining in recent years in favor of urea. South Africa's demand for urea is only around 0.5% of the total world demand, so we are not a very significant player. The whole of our region consumes less than 1% of global urea. Urea is produced in around 65 countries around the world, so it is a very widespread production base, and therefore we see quite a healthy commodity market because there are a number of producers that compete with each other for the same business. So we see that urea capacity utilization is around 86%, which is a high number when we consider that there is a lot of urea capacity around the world that does not produce too often. Places like China and Russia have quite a few surplus plants that are very old and typically only come into production when prices are high. On this map, I've highlighted the major production centers as well as the major trade flows. The yellow circles show countries that are net importers, so even though they may have substantial urea capacity, they still require some imports of urea to meet their local demand. The blue circles show regions that are net producers of urea. Typically, these are regions with abundant natural resources, such as natural gas or coal, and very little local demand. So places like North Africa and the Middle East are big surplus producers of urea, and we see that the arrows typically flow from those regions to the big grain-producing areas around the world. A point to note that China is self-sufficient in urea, but other countries within its region, such as South Korea and Japan, are large importers. So overall, we see the East Asian region as a net importer. The converse is also true for regions such as Western Europe and South Asia. And by South Asia, we're really referring to India. These are regions with large agricultural sectors and insufficient local production of fertilizers. So they import very large volumes of their fertilizer needs. They do not have the raw materials necessary to produce urea. Another point to note in the world map is that the Northern Hemisphere market, and if we just draw a line through the middle of the map, you can easily envisage that. The Northern Hemisphere market is substantially larger than the Southern Hemisphere. The global industry is therefore designed to meet the peak demand for the Northern Hemisphere, and we have different seasons between North and South. So the industry must meet the peak demand of the Northern Hemisphere in Q4 and Q1, and therefore in the Southern Hemisphere demand season, there is nearly always surplus production available. We believe strongly that this is the time period for our region, Sub-Saharan Africa, to take advantage of this seasonal pricing. So Q2 and Q3, which is the Southern Hemisphere demand period, is the low point in the annual price cycle. This is a theme that you will hear repeated throughout our videos, that the annual price cycle does create some opportunities for Southern African farmers to specifically focus the timing of their purchasing. Here I've highlighted the cost or the project economics for new capacity. The cost of production is a key price driver for all fertilizers or for all commodities. If the international price stays below the production cost for any given producer, then we can expect that loss-making plant to close at some point in time. Typically, we see the low points in pricing only last for a few months. So it's not usual that we have widespread capacity closure, but these periods do happen. On the other hand, if the urea price stays high for a sustained period, we see that producers or countries with the necessary raw materials start to look at the investment case for more capacity. As a punchline, the cure for high prices is normally high prices, because high prices mean more capacity is built, and more capacity means more supply, and our global supply-demand balance becomes more even. In this slide, we've got the example of the CF Industries projects in the USA. A world-scale ammonia urea project these days produces around 1.2 to 1.5 million tons of urea. That's really the economic scale for urea production. The capital cost of such a project is around $2.5 billion, and construction takes 3 to 4 years. The rationale for these particular projects was the emergence of shale gas in the USA, which resulted in natural gas prices dropping quite substantially, and therefore the production cost economics were favorable for new capacity. As we can see, the cash cost of production for urea in these plants is around $135 a ton, which is well below the current price today, which is north of $400. Keep in mind that there is a payback of capital that is required and is over and above this $135. But even so, the payback for such a project would be in the order of 5 to 7 years. And these projects return an IRR of greater than 15%. So quite an attractive investment proposition. The Middle East is also a key producer for our region in Sub-Saharan Africa. Gas prices are even lower in the Middle East, so bear in mind how low cost the Middle Eastern producers must be. It really underlines why production in our region does not really make economic sense. Here we have a picture of the Donaldsonville site for CF Industries. It's on the Mississippi River, which you can see in the background. The site has its own jetty and the capability to load ocean-going vessels, as well as loading barges that flow up the Mississippi River and supply the Corn Belt. So the logistics cost to market for such a plant is very low. Compare that to logistics in our region, where all fertilizer has to go by road, and our road infrastructure is creaking at the seams. Here I've summarized the major drivers which we focus on when considering nitrogen prices. Virtually all of these factors can be grouped either as supply-side drivers or demand-side drivers. Some of these factors are also more local in nature, and others are more international. Similarly, the time duration that these factors may impact the market can vary from a short-term event, such as a plant breakdown, or a long-term event where there may be a trade barrier imposed on a particular country. Ultimately, it is the supply-demand balance within a particular region, or the agglomeration of supply-demand balances overall at a global level that determine the price. So monitoring the factors listed in the table and assessing their impact on either supply or demand is key to understanding price trends. In this calendar year 2021, we see around 11 million tons of new urea capacity coming on stream. This is 5% of overall capacity. Keeping in mind the projects typically take 3 to 4 years to complete, capacity growth or closure is a factor that can easily be monitored. Energy prices are another key cost driver or supply-side driver. Gas is the main raw material for ammonia and urea production, so rising gas prices for urea producers will have a direct impact on the cost of production and ultimately the ability of that producer to continue to produce. Where the natural gas market price floats in places such as the USA and Europe, there is a risk for producers of gas prices rising faster than urea prices. In other countries, we see that gas prices are fixed in places like the Middle East, and these producers are typically low cost and remain low cost for a sustained period. So we can rely on those producers to continue to produce irrespective of market conditions, whereas high-cost producers, such as those in Europe, will typically cut back on production if urea prices drop. I'd like to bring attention to a big demand-side flag for urea, which is that of tenders. India, for example, imports around 8 million tons of urea per year on a tender basis. These tenders take place in tranches of 1 to 2 million tons and typically arise at short notice and require fulfillment or delivery of product in a very short time frame as well. So the net effect of this is the Indians coming into the market often removes a substantial chunk of available urea and has an impact on price as a consequence. Another key factor that I want to identify out of the list is that of shipping. For all importers, the urea must be shipped from the production point to that country. Shipping prices in the last 18 months have more than doubled. So as a cost component of urea, the shipping one has really changed in significance. So that wraps up our overview on nitrogen fertilizers. Hopefully it's been informative. I would just like to recap the key points. The cost of production is driven by the scale of the production plant and the cost of its raw material. There is a strong long-term correlation between oil and natural gas prices and nitrogen fertilizer prices. We've also seen how global trade takes place to meet demand in regions that do not have enough local production capacity by transporting product from the low-cost producing regions. The cost of ocean freight is also a key cost determinant. The timing of the seasons, Northern Hemisphere versus Southern Hemisphere, also drives a price cycle within the calendar year. We've listed a number of supply and demand factors that we track that help us take a view on nitrogen price directions, and we would love to discuss these with you. I hope that you've enjoyed this video, and we'd love to hear from you, whether you have comments or questions or wish to discuss further with us. Our contact details are available below. Thank you.